Hi, everyone. I'm Rob Rowe, U.S. Regional Director of Research. Welcome to the Research at Citi podcast. Today, I have on the podcast with me Peter Lee, who is our head of semiconductor and IT hardware analysis at Citi Research. And our topic today is an interesting one. There's been a recent introduction of TurboQuant, and we're going to discuss how this new technology may have profound effects on memory and storage demand. Welcome, Peter, and thanks for joining us.
Hey, thank you, Rob.
You know, this has actually taken the market a little bit by storm, hasn't it? I mean, maybe what we should do first is just talk about the introduction of TurboQuant recently by Google. What is TurboQuant and how does it work?
Yeah, sure. The TurboQuant is AI memory compression, and it was designed to solve one of the biggest bottlenecks in running the large language models. So the massive amount of memory required to store the conversation context, known as the KV cache, key value cache. TurboQuant allows the AI memories to run faster and handle much longer conversations on existing the hardware by shrinking the size of this temporary data by roughly 6 times without losing accuracy. So TurboQuant works by transforming the complex data vectors into a much simpler. So instead of using the standard XYZ coordinates, converts the data into radius and angles. So because the rotation makes the angle follow as a distribution, the system doesn't need to store the extra metadata to describe how to decompress the data, saving the significant space. So that's actually a very innovative approach to reduce the memory size.
So I know that there are some views that this is negative for the markets or negative because it could cannibalize some memory companies or something along those lines. How do you foresee memory demand changing? Does this reduction in KV cache enable by TurboQuant to lead to a decrease in memory demand, or do you think there's something else happening here?
Yeah, I think that this kind of software efficiency isn't a threat to memory. I think it's positive for demand because it makes AI cheaper and more useful, which drive a virtuous cycle of even higher demand for the advanced chips. So I think it's like Jevons paradox. So I think it will be more positive for high performance memory like HBM and SerDF5.
So there's essentially a cost efficiency here as well, which I know has been a concern for AI too. Can you give us other examples of what you just mentioned, which is Jevons paradox?
Yeah, sure. Maybe the cloud computing, for example, actually, when I was in Samsung Electronics before I joined Citi, I was in the marketing division. At the time, people were actually worried about the demand correction or negative demand correction from cloud computing because cloud computing is more efficient. So we don't need maybe PC much. That's concern in the market at the time in the memory industry. But the opposite thing happens because people start to use cloud computing more, and then it's more efficient. So computing cost is getting cheaper and cheaper. So people use more computing actually systems. So that's actually the kind of one example of the Jevons paradox, I think.
You mentioned that TurboQuant is a quantization algorithm that reduces KV cache memory use by 6 times maybe? Then what is KV cache? So this sounds like a rather significant innovation, am I right?
Yeah, right. So think of KV cache as kind of bookmark for every word in a conversation. So normally, when an AI agent talks to you, it has to reread everything from the very beginning to decide what the next word should be. So instead of rereading everything, the AI writes down a summary note for every word. So the AI keeps these note cards on memory. So that's why that's actually, and then we call it KV cache. It's kind of short-term memory.
And maybe I can go back, Peter, to the previous question, which is how do you think TurboQuant will affect the future direction of the memory market in general?
Yeah, I think the TurboQuant could impact the edge device. So we think that the PC smartphone, for example, could be kind of personal AI in the future. So maybe the people can use the AI with smartphone or PCs because we can shrink the model size and also shrink the KV cache more. Then we have enough room to operate the AI model or AI computation. So I think that by making memory requirements smaller, so TurboQuant allows the powerful AI to run on the smartphone and laptops instead of just massive data center maybe in the mid-long term. So this move of memory demand from a few thousand servers to billions of personal devices in the future, I think.
So let's focus on that for a second because I think that's a key thing that you just mentioned. So this KV cache quantization can potentially enable a lot of edge devices potentially to run massive models that were previously restricted to data centers. Is that right? Or to what extent can people start running things on edge devices?
So yeah, I think the concept is very simple. Like we can compress the data, then we can make it smaller. Then some kind of simple AI the operation could be happen in the PC and smartphones, like edge device. Maybe I think it could be like PC or smartphone and even robots, maybe, and or glasses in the future. I think that the people could use the AI stuff and then it could be more efficient. So memory is so efficient. So the AI doesn't need to send your data to a cloud server. So it does all the thinking locally on your device. So which is kind of faster and more private. So maybe they could be more powerful for AI, especially for the privacy and speed.
Wow. So does that mean that it could also put less demand on data centers?
No, I don't think so because they could be maybe cooperate together. Like AI server is more could be used for like high performance and high workload maybe. But the personal device, maybe we can do some simple AI. We can do operate AI models. So it could help each other maybe, I think.
And Peter, when we think about this innovation, what's the timeline to full deployment, do you think? Is it fully deployable now? Is it something that is an innovation that's complete, or is it something that still requires development?
I think it's still required development, but maybe they are trying to working on it. But in terms of personal AI, we think that could be will coming in 28, but it could be mild transition from AI server to personal AI in the future. But I think the people are trying to use this kind of technologies. But the meaningful changes, I think that it could be it will start from 28, I think, yeah.
And what sort of timeline do you think that would be towards, say, full deployment of this new innovation?
Maybe just this year, the second half, maybe there could be some introduction maybe of the kind of compression technology maybe. And then could be gradually used in 27. But maybe the edge device makers also need to prepare the new directions. And then also memory makers also need to prepare for the edge device or personal AI stuff. Then I think they take some time. So the meaningful changes will come in 28 because the hardware for like edge device also need to change to operate the models in the edge device. That's why we think that it's starting from second of this year gradually, but the meaningful changes will come in 28.
Yeah, I imagine there might be other adjustments to smartphones or to iPhones that would have to be made to accommodate for this kind of memory compression, no?
Yes, right. So, and also we need a more high bandwidth memory. So which means that we need more lanes in the road because to operate the AI model and AI KV cache kind of stuff, we need more IOs, which means that we need more require high bandwidth. So then the current DRAM and NAND in the smartphones, I think that is not enough. So for example, like so came to LPDDR6 maybe also could be the solution for the edge device to operate the AI models in the phones.
Oh, and is there an issue where you said you could have your own personal AI on your smartphone? When I think about that phrase, it seems like it's separated from the main AI. If you're using that, how are you using it separately on your phone versus the one that's connected via the cloud?
Yeah, very good question. I think maybe that it's up to you. Maybe if you don't want to open the certain information, maybe kind of privacy information, then you don't want to share, then you do the models and then the operate the AIs in your phone or your edge device. So maybe you can choose maybe that. But if you use more high performance AI, then maybe you can share your information to the cloud. Maybe I think so. Maybe there could be some option. I think, or you encrypt the information maybe in a server smartphones. Your AI model, personal AI models, a little bit encrypt the information, and then they will operate the data in the server, and then beam back to your PC smartphones, and then decompress that information. Then maybe there could be some other way to operate the models. I think so. I think that server and edge device is not separate. I think it'll be linked together, but you can choose the information, maybe the range, maybe that private, because some people don't want to share the information maybe.
Wow. I wouldn't have thought that something so such as being able to have extra memory by compressing or having this efficiency, would lead to some significant changes within the world of IT and with the world of AI. But this seems to be a significant change.
I think the TurboQuant is the early stage now, but I think that anyway, that will be better for the cost saving. So I think that it will bring the more demand. So that's why we think that it could be positive for the AI memory demand. And also in the future, the TurboQuant could impact the edge device. So then also will be positive for the memory demand increase from the edge device like PC and smartphone in mid long term.
So in some sense, Peter, this is more of a positive outcome even for the memory industry, if you will.
Yes, I think that's kind of net positive for the memory industry.
Peter, thanks again for being on the podcast. This is obviously a very intriguing innovation that we're going to have to keep an eye on going forward.
Yeah, sure. Thank you.
Thank you. This podcast was recorded on April 7th, 2026. Be sure to join us for our next Research at Citi podcast, The Macro-Micro Disconnect of the AI-Driven New Economy in China, with Changrong Yu, Citi's chief China economist, and Alicia Yap, the head of our Pan-Asia Internet Research at Citi. Feel free to explore our library of previous podcasts and multiple subjects, all of which are available on this channel and other channels as well. And also be on the lookout for our Research at Citi Markets Edition podcast with its 10-minute breakdown of the equity and global macro markets each and every week.
This podcast contains thematic content and is not intended to be investment research, nor does it constitute financial, economic, legal, tax, or accounting advice. This podcast is provided for information purposes only and does not constitute an offer or solicitation to purchase or sell any financial instruments. The contents of this podcast are not based on your individual circumstances and should not be relied upon as an assessment of suitability for you of a particular product, security, or transaction. The information in this podcast is based on generally available information, and although obtained from sources believed by Citi to be reliable, its accuracy and completeness are not guaranteed. Past performance is not a guarantee or indication of future results. This podcast may not be copied or distributed, in whole or in part, without the express written consent of Citi. Copyright 2026 Citigroup Global Markets, Inc. Member SIPC. All rights reserved. Citi and Citi and Arc Design are trademarks and service marks of Citigroup Inc. or its affiliates and are used and registered throughout the world.